getting at. Okay, so what I would like is to let y be 2 plus x. So therefore dy equals dx. And I will solve this equation for x, which is y minus 2. So therefore, the integral becomes, instead of x squared, I have y minus 2 squared. Instead of the square root of this, I have y to 1/2. And instead of dx, I have dy. I will have to expand this into y squared minus 4y plus 4. And I will distribute y to 1/2 to all three terms. Y squared times y to 1/2 is 5/2, right? Minus 4, 1 plus 1/2 is y to 3/2. And then plus 4, y to 1/2. Is this clear? We did the same thing? Okay, so then I have y to 5/2 plus 1, which is 7/2. Y to 7/2 over 7/2 minus 4. Y to 5/2 over 5/2 plus 4. Y to 3/2 over 3/2 plus a constant c. I flip all these and I have to replace y by 2 plus x. So this is 2 over 7, and I have x plus 2 or 2 plus x to 7/2 minus 8 over 5, x plus 2 to 5/2 plus 8 over 3, x plus 2 to 3/2 plus a constant c. No, you don't have to do anything else. Would we like to choose anything else from here? I remember we did a lot, but maybe not enough, so please choose anything you want.
48.
48. 48. Very good. So that's the integral from x to the third,
It's similar,
but not the same. Right. The integral from x to the third, the square root of x squared plus 1 dx. Very good. 2 minutes? So let's work on this for 2 minutes. Do we have an answer? Do we need more time? Okay.
I actually think it's pretty cool. Oh, sorry. Oh, let's turn off the. Oh, it's pretty loud. But I actually think it's pretty cool because some of the things that you're teaching right now, I remember back when I was taking the AP test back in high school, like these were the exact integrals that stumped me.
Made you think. Okay,
Like,
good, good. Ready? Okay, so what would you say the substitution would be? Good. I agree with that because we really want to get rid of that square root. So let y be x squared plus 1. So then dy will be dx. So I have to break this into x and x squared. So multiply by 2 and divide by 2. Therefore, I have 2x dx. This and this will be dy. This is dy. So this will be the square root of y. And what about x squared?
X squared is y minus 1.
So x squared will be y minus 1. Let's put everything together. 1/2 in front, the integral from.
The integral
1 minus 1 times. I will write y to 1/2 times. That's it. I will distribute it. So this is 1/2 the integral from y to 3/2 minus y to 1/2 dy. And now I will find the antiderivative. 1/2 is outside. So then y to 3/2 plus 1, which is 5/2, over 5/2 minus y to 3/2 over 3/2. And then I flip. Of course, plus a constant c. So this is 1/2. 2 over 5, y to 5/2 minus 2 over 3, y to 3/2. And plus a constant c. So this is 1/5, y to 5/2 minus 1/3, y to 3/2 plus a constant c. And yes, now I have to go back and replace y by x squared plus 1. So the final simplified form will be 1/5 x squared plus 1 to 5/2 minus 1/3 x squared plus 1 to 3/2 plus a constant c.
So why
Yes.
is the 1/2 not also applied to the constant?
That's true. So if you want to put the constant in,
So
yeah. So then this will be c1, and when you apply 1/2, it will be c2. It's not going to make any difference. You can rename it. Very good question. Thank you. Okay, so can we do something else now? Okay, so I am given the velocity as 2x minus 4. And I'm asked two things. One, find displacement. Number two, the distance traveled by the particle during the given time interval, and I'm going to choose between 2 and 4. So find total distance for the interval 2, 4. I have to change it, I'm sorry, for the interval 1, 4. Okay, 3 minutes. Let's work on this. Can anyone give us the hint for number 1? What do I have to determine? Right. So for number 1, I have to find s of t, which is the integral from 2x minus 4 dx. It's a function. We're not talking about the definite integral, and it's not a number. It's the displacement, which is the function, the antiderivative of v. Excellent. So then this is 2x squared over 2 minus 4x plus a constant c, which turns out to be x squared minus 4x plus a constant c. Done. Can anyone tell us how to start number 2? What are we asked to determine in number 2?
Distance, so you evaluate this
Careful. No. It's 2x minus 4, but thank you very much. Because remember, the particle can do this, so I have to add all those distances. Good. So please determine the absolute value of 2x minus 4. Get the function going. And then you will have a sum of 2 what? 2 definite integrals. Excellent. Okay, so there are 2 options. One option is 2x minus 4 if greater than or equal to, very good, or negative 2x plus 4 if x is less than 2. Good. So therefore, this will equal a sum of 2 integrals.
So from 1 to 2, or negative 2x plus 1. And then from 2 to 4, 2x minus 4.
Good. So then we have negative 2 x squared over 2 plus 4x from 1 to 2 plus 2x squared over 2 minus 4x from 2 to 4. And I have to plug in those numbers. First, I plug in the top, and I get -4 plus 8, minus when I plug in the bottom, -1 plus 4, which is 3. Plus, when I plug in 4, I have 16, oops, minus 16, nice, minus 4 minus 8. 4 minus 8 is -4. So this is 4 minus 3 is 1. 1 plus 4 is 5. So the total distance covered by the particle between time 2 and time 1 and time 4 is 5. Any questions? Any questions? Questions? Okay, I would like to look at the next problem. 58 on page 395. Uppercase F is given in the form of an integral. From the square root of x to 2x from arctangent t dt. In this problem, we can only be asked to do what? For such a function defined as an integral, we can only be asked one thing, which is to find what? To find the derivative, not the antiderivative. I can't solve this. This is a function given in the form of an integral. Since the limits of integration are functions themselves, I can only be asked to find the derivative of this function, and I will have to differentiate both sides. But I cannot differentiate the right-hand side just yet. So this is the fundamental theorem of calculus part 1. It's what?
Is it arctangent of x dx?
No. You are on the right track, but the answer is no.
We're going to split it up into two.
Right.
Where it's like 0 to 2x and 0 to the root of x.
I have to split it in the middle.
Right.
So then f of x is the integral from the square root of x if you want to any number you want.
Right.
From arctangent t dt plus from any number you want, the same number, to 2x from arctangent t dt.
And then you have to make it one negative.
Exactly, negative from that number to the square root of x arctangent t dt plus now I'm ready to differentiate both sides.
That's all.
So then, what do I have to write? Now I differentiate this, and I differentiate this.
So you have
F prime of x equals,
negative arctangent x times 1 plus 2 squared root of x,
excellent, plus,
arctangent of 2x times
excellent. Of course, you cannot simplify. This is separate from that. And this is separate from this. So you can rearrange it if you want, and I would. 1 over 2 the square root of x, arctangent the square root of x, plus 2 arctangent 2x. When a function is given in the form of an integral, you can not be asked to evaluate the integral. All you can be asked is to find its derivative. Okay, let's look at one more. What about 14? H of x equals the integral from 1 to the square root of x from z squared over z to the 4th plus 1 dz.
What page are we on?
394. So what can I be asked here? Since it's a function in the form of an integral,
Derivative.
just the derivative. So let's find h prime. And then I would like to go back to Riemann sum.
So since it's a number at the bottom, we just substitute the root of x.
That's
to
it.
c, correct?
That's it. Yes, you don't have to rearrange it. You don't have to do any preliminary work on it. Correct. So what do I have?
X over x squared plus 1.
Two square root of x.
Very good. I would like to look at some properties. I think we did problem 57 on page 384, and I would like to look at one more. Yeah, let's give it a shot to 56 on page 384. We're asked to show this. And then I would like to look at a Riemann sum and evaluating an integral that we cannot find the antiderivative for, which is very useful. Okay. We're not asked to evaluate, even if we could evaluate these two. We are not asked to do that. We're asked to use the properties of definite integral to show that this is true. Where do I start? Where's the starting point?
X.
Right. Being between what and what? Right. Here they are, right here, the limits of integration. Good. Now I would like to form this.
So is that 1?
So I'm adding 1 to all three sides.
Right.
Very good. Okay.
Square root of both sides.
Right. So I take the square root. So then it's 1 less than or equal to the square root of x plus 1 less than or equal to the square root of 2. So far so good. Just leave it alone for a moment. So I kind of have an idea of what's happening here, right? Okay. Now I would like to look at this. Where do I start? Again with x. But how do I form that first?
Square it.
Right. So now for a number between 0 and 1, when I square,
Still between 0 and 1.
okay, I agree. Then I will add and then I will take the square root. And then I get this, which doesn't really help me. So I established the fact that they are somewhere in the same ballpark, right, between 1 and the square root of 2. But now what I would like to do is compare, because that's really what I really need, right? I would like to compare these two. So which of these two, for a number, this is crucial, for a number between 0 and 1, is 1 plus x squared or 1 plus x bigger? Do you agree that 1 plus x, because for a number between 0 and 1, for a number between 1 and, exactly, for a number between 1 and 2 is a different story. But for a number between 0 and 1, this is definitely bigger than this. Would you agree? So then the square root will be bigger than the square root of this. And therefore, once I establish that, then I'm done. That's all I had to show. So for the interval between 0 and 1, 1 plus x squared is smaller than 1 plus x. The square root from 1 plus x squared will be then therefore smaller than the square root of 1 plus x. And now I'm allowed to, this is one of the properties, if you remember, if this is f of x and if this is g of x, this area is smaller than this area. So therefore, that is true. Let's also work on 58. It looks interesting. And then we'll go back to Riemann sum. So this is the square root of 2 pi over 24. They say again, we are not asked to evaluate. We are only asked to show that this is true. We're not asked to evaluate this, and evaluate this. Okay, here's a number between these two. I'm done. Where do I start? I have to start with x. Okay. So I start with x, and x is between and pi over 4. What do I have to do to all three sides now?
Cosine.
Right. Do not write the inequality symbol. It depends. If the function is increasing, cosine of pi over 6 will be smaller than cosine pi over 4. But if the function is decreasing, cosine pi over 6 will be bigger than cosine pi over 4. So I have to think about this. So I'm going to graph a little bit of cosine. So I know cosine looks like this. So at 0 is 1, at pi over 2 is 0, then negative 1, then 0, and then 1. Pi over 6 is here, 30 degrees. Pi over 4 is here because it's 45 degrees. So this height and this height, how do I keep the inequality symbols? Which one is smaller? Right. Because the function is decreasing. As x increases, y decreases. So now I have to read the inequality from here. Cosine pi over 4 less than or equal to cosine x less than or equal to cosine pi over 6. Now I know the numbers. Cosine pi over 4 is, they're both the same. It's the only angle that has the same sine and cosine.
32.
And this is cosine pi over 6 is not 1/2. What is the other number?
3/2.
Right. So now, the middle is clear. I'm not allowed to touch it. I take the constant outside. What function prime is 1? Oops. Good. So now when I plug in pi over 4 and I subtract pi over 6, I get, so let's calculate that, pi over 4 minus pi over 6. The least common denominator is 12. I have a 3 and a 2, so this is pi over 12. So the square root of 2 over 2 times pi over 12 is the square root of 2 pi over 24. dx, of course. And again, the square root of 3 over 2 times this, which is the square root of 3 pi over 24. I look back at the problem and see if I got what they wanted me to determine. The square root of 2 pi over 24, the square root of 3 pi over 24. Ready for limit of the Riemann sum? Okay, here is an example that is very important and very useful. So let's say I would like to determine the integral from 2 to 3 from e to x squared dx. There is no antiderivative for this. And let me say, okay, I'm going to ask you to find or approximate this integral using midpoint rule and 4 subintervals. I'm going to change, bless you too. I'm going to change this into 10 so I make it easier on you. So we're asked to find an approximation for this integral, which is the area between 2 and 10 under e to x squared, using the midpoint rule, not the left point, not the right point, but the midpoint with 4 subintervals. With 4 subintervals, do you think the approximation will be good? With 16 will be better, with 32 will be even better, with 64 will be better, with infinite will be the best. But I will not torture you with more than 4 subintervals. So let's approximate the area using 4 subintervals. First, I would split the interval, right, to see it. So I will prepare my work from 2 to 10. 1, 2, 3, 4. Of course, my intervals are not. So 4, 6, and 8. So the middle one is at 3, the middle one is at 5, the middle one is at 7, and the middle one is at 9. So then I will have base times height plus base times height plus base times height plus base times height. So approximate this integral using the midpoint rule and 4 subintervals. Let me know when you are ready to dictate. I cannot use the equal symbol. It has to be the approximation. Okay. Can anyone give us? Yes. 2 is outside. Good. E to the 9th plus
E to the 25th,
plus
E to the 29th,
Very good. Very good. Whatever that is. Is that clear? So this will be an approximation of the area under the graph, or the approximation of the integral. We'd like to look at the limit of the Riemann sum. Okay, give me any function you want, quadratic or cubic. We are restricted to maximum cubic.
Let's go with x cubed plus 3x. That's it.
I wanted to go through all of them, but that's fine. That's good. And the interval. If you're nice, you're going to start with 0. If you're semi-nice, you're going to start with anything else. We can start with 1. Okay, well, let's say 1 to 3. Good. So we know that the area, which we can check, is the integral from x to the third plus 3x dx, which we will check with later. But this is also what I'm trying to determine is the limit as n approaches infinity from the sum of delta x f of xi from I equals 1 through n. So it now I started coughing. Now I need prep. I need 3 preps for this. Number 1,
Delta x.
number 2,
X.
and number 3, f of xi. Excellent. So let's find delta x first. Very good. Let's find xi. Now xi is a little bit more difficult because it starts at 1. So it's 1 plus I delta x, which will be 1 plus 2 over x.
Isn't it 2 over n?
Oh, yes, of course. I'm sorry. Times I. So now the difficult part is that it's x to the third, and it starts at 1. So first I have to, this is aside, 1 plus 2I over n, I have to raise it to the third power, which will be, I know the formula, but I don't want to mess you up with the formula. So I have 1 plus 2I over n squared times 1 plus 2I over n, and then I'll have to square this and then distribute this. So 1 plus 2 times the first times the second, 4I over n, plus 4I squared over n squared, and now I multiply again by 1 plus 2I over n. Is this clear? Yes? So 1 times all these 3, and this times all these 3. So this whole thing is 8I to the third over n cubed plus 12I squared over n squared plus 6I over n plus 1.
That's just x cubed.
This is just x cubed. So therefore, we have f of x now, f of xi, which is all this 8I to the third over n cubed plus 12I squared over n squared plus 6I over n plus 1 plus 3 plus 6I over n. So therefore is 8I to the third over n cubed plus 12I squared over n squared plus 12I over n and plus 4. So please take it from here and find both the limit of the Riemann sum and the definite integral to check.